The theory of the Big Bang is the widely accepted origin story for the beginning of the universe, a point in creation where all life we see and observe today came from an infinitesimally small speck of dense hot energy. But before the Big Bang, most scientists say there was nothing, no space, no time, no universe, just nothing. But the thing is, something had to have been responsible for creating the Big Bang, as nothing cannot produce something. So in today's video, we're going to answer a very fundamental question. If the universe formed from nothing, who created nothing? Science today has a really firm picture of the very early stages of the universe, something we have all come to study and understand as the Big Bang Theory. In this origin model of the universe, a little over 13.8 billion years ago, the universe was incredibly small, hot, and denser than it is today, to such proportions that there are no measurements in mathematics that could capture the dense and hot nature of this early universe. In that early universe, all elements and particles that make up what we see and observe today were created within the span of a few minutes. During this point in creation, everything we see today in the observable universe, including galaxies, stars, and all the planets, were contained in a space smaller than a peach and had a temperature of well over a quadrillion degrees. With evidence from current observations, astronomers have been able to observe the leftover electromagnetic radiation from this young universe. They have been able to measure and calculate the abundance of light and elements that line up to explain not just the theory of the Big Bang, but also the processes that led up from that point to the current stage of existence. But even as astronomers have been able to observe up until the early stages of the Big Bang, there still remains a key piece of the theory that is yet unexplained, which is what preceded the earliest moments of the universe itself. This one question scientists and astronomers have been asking for decades, and it seems now there might finally be an answer. The singularity. Scientists have been able to explain that the universe itself began from a singularity, which is a single, unimaginably dense and hot point that occupied a space much smaller than an atom. This singularity didn't already exist in space, but rather it initiated the explosion, expansion, and subsequent cooling of space-time itself. In other words, the singularity that resulted in the Big Bang existed in nothing but contained everything. The singularity is believed to have had the precise amount of energy and heat needed to balance the creation of everything we see and observe in the universe today. In other words, if the singularity was a few degrees hotter or colder at any point during this expansion, none of what we see today would have been possible, including our very own existence. But however magnificently precise the singularity that resulted in the Big Bang was, it even further begs the question of what could have created such a perfect combination of energy and heat. What most scientists will say is that the singularity resulted from nothing, and before the singularity, there was absolutely nothing. There was no space, no time. But within a trillionth fraction of a second, the singularity came into existence and expanded into the Big Bang. This has been widely regarded as the theory of nothing. But the theory of nothing upsets every law of physics and quantum mechanics that governs the observable universe today. As the most basic law of physics states, nothing can be created from nothing. For something to exist, there must have been something, or a combination of pre-existing components for something to be created, in this case, the singularity that resulted in a Big Bang. For decades, scientists have struggled to explain this state of nothingness, to see if there are observable theories that could explain how nothingness could result in the perfect circumstance to create something as magnificent as the universe. In this, scientists looked further into the future, to the very end of all existence, to what has been termed the Big Freeze. In this theory, scientists believe that as the universe continues to expand beyond points where stars can no longer generate enough heat and energy to warm up the universe, they would slowly cool and fade away. With the fading of the last stars in the universe, the entire cosmos will be plunged into an infinitely long and dark era where the only active cosmic beings would be black holes. As the universe continues to expand and freeze, these black holes would consume every last bit of matter left in the universe. This would eventually reach a point where there is no light or matter left in the universe for these black holes to consume, and they themselves will begin to fade away. Space will continue to expand outward until a point where there is absolutely no light or matter in the entire cosmos. This future prediction of the end of our universe, where the entire cosmos essentially fades away into nothing, has been likened to the point of nothing which preceded the Big Bang. Some scientists believe that the future desolate end of our universe could be the perfect situation that might have resulted in the singularity and created the Big Bang. In essence, the death and end of a previous universe could have laid the very foundation that created our own. But before we get into how our universe was created from nothing, let's first trace far back to the earliest stages of the Big Bang to understand how nothing gave way to the very first atomic materials that made up the observable universe. Scientists do, in fact, have a very detailed picture and understanding of how and when the first atoms formed from much simpler particles after conditions in the early stages of the Big Bang became stable enough for these particles to fuse into atoms and then larger elements. Looking at the very first second of the Big Bang, the first initial long-lived particles of any kind were neutrons and protons, which fused together to make the atomic nucleus. These subatomic particles came into existence at around 1/10,000th of a second after the explosion of the Big Bang. Scientists have observed that before this point, there was simply no actual matter of any material that existed in the entire universe. But still, the laws of physics and quantum mechanics allow us to push the timeline further back into the most primitive stages of the universe to observe as close to the point of nothingness as we possibly can. This takes us back to a relatively unexplored area of the earliest universe called the Grand Unified Epoch. Entering this realm of the earliest point of the Big Bang is well into the field of speculative physics. This is simply because although scientists postulated theories as to what might have happened during this era of the earliest universe, we are simply unable to reproduce any of the conditions or processes at that time. But the generally accepted hypothesis is that the physical world at that time, which was roughly a millionth of a second into the Big Bang, was made up of a dense soup of short-lived elementary particles which include quarks, the fundamental building blocks of neutrons and protons. At this point in time, there was both matter and antimatter, both existing in roughly equal quantities. Each type of physical matter, such as quarks, had a corresponding antimatter or mirror image companion, which was almost identical to itself, only differing in one major aspect. But as we've observed in the universe, matter and antimatter annihilate themselves in flashes of high boost energy when they meet. This means during this point in the Big Bang, particles were constantly being created and destroyed as the universe existed in a constant state of nothingness and something at a point that lasted a mere fraction of a second. Still on a journey of tracing back to how the universe moved from nothing to something, the big question comes as to how these particles themselves came into existence in the first place, since there was essentially nothing before the Big Bang. We now move into a realm of physics known as quantum theory, which tells us that even in an empty vacuum or empty space-time in this case, there is a mirage of physical activity in the form of energy fluctuations. These energy fluctuations are practically invisible but are powerful enough to give rise to particles in an unstable state in which they are known to disappear shortly after being created. This may sound like a theory from a sci-fi movie, but such energy particles have actually been observed in countless experiments here on Earth. The space-time vacuum in the early universe was filled with these energy particles, constantly in a state of creation and destruction, apparently resulting out of nothing. But then again, this poses another question, or rather a statement, that the quantum vacuum or vacuum of space-time at that point in the Big Bang was actually something instead of nothing. And since science apparently has an explanation for the rise of matter in the form of energy fluctuations during the early stages of the Big Bang, we can now ask the most basic question: where did space-time itself come from? To answer this question, we must further push back beyond the boundaries of the Big Bang to a truly ancient era of creation known as the Planck Epoch. This period of the universe is so primitive that all the laws of physics seem to break down. This area of the Planck epoch occurred only 1/10,000,000th of a trillionth of a second after the Big Bang and remains the earliest stage of the Big Bang creation theory of the universe. During this point in creation, both space and time were subject to powerful but incredibly dense quantum fluctuations. Physicists have stated that quantum mechanics is significantly different from the rules of normal physics, which are governed by Einstein's theory of general relativity. In essence, quantum mechanics explains the rules of the micro-world particles in which processes take place within trillions of fractions the size of a proton, while general relativity applies to the larger cosmic scale processes of the universe. But in order to understand the processes of the Planck epoch, we need to combine both the theories of general relativity and that of quantum mechanics, which both merge to give rise to the theory of quantum gravity. Scientists currently do not have a perfect postulation for the theory of quantum gravity simply because the processes that have been hypothesized are nearly impossible to create in order to be observed. There have been attempts to understand this process, but the consensus that remains among scientists is that what we have come to experience as space and time is a physical representation of quantum processes operating at multiple microscopic levels. These quantum processes do not make much sense to us physical creatures, as they are rooted in microscopic principles that we are simply unable to study at this point in our existence. During the Planck epoch, our basic understanding of space and time do not apply, with the principles of cause and effect being basically irrelevant. Hence, we cannot rely on our current understanding of physics to study this period in our creation. But despite our limited understanding of quantum gravity, all hypotheses point that some kind of quantum or physical process was happening during the Planck epoch, which resulted in space and time. But another major question arises: where did those processes come from? Some scientists have stated that even if the principles of cause and effect no longer apply during the Planck epoch, it is still possible to explain some minor components of that era of the universe, but in relation to another. The general consensus among scientists still remains that although they are unable to physically observe and study that era of creation, one thing remains certain: in the entire observable universe, nothing arises from nothing. Therefore, the processes of the Planck epoch must have been the result of some pre-existing process or entity. Cycles from nothing. All attempts to answer the processes that result at the beginning of the Planck epoch have all come to a similar conclusion. The era of creation must have existed as a result of a pre-existing factor. Some explanations have gone as far as stating that it was a result of supernatural forces or a divine being. But before we jump into the chances of the existence of a god, there are still theories that physics can still explain. Such explanations include the existence of a multiverse, which states that there are an infinite number of parallel universes, but this still leaves the question of how each universe is created. The more likely and widely debated scenario is the existence of a cyclical model of universes, whereby the death of one universe leads to the birth of another and an infinite cycle continues. This brings us back to the theory of the big freeze and the nothingness at the end of our universe's existence being quite similar to the nothingness that precedes the Big Bang. Scientist and Nobel Prize-winning physicist Roger Penrose postulated this plausible but highly controversial model for a cyclic universe, which he termed conformal cyclic cosmology. As stated, Penrose revealed he was inspired by the intriguing mathematical connection between the very cold, empty state of an expanded, dead universe and incredibly dense and hot, small state of the beginning of our universe during the Big Bang. His highly radical theory aims to explain the correspondence and similarities between those two states, as they're almost mathematically identical when taken to their limits. However, impractical or paradoxical as it may seem, a complete and total absence of matter, which would be the case at the end of our universe's existence, may have managed to give rise to all the matter we see around us in our current universe. Penrose's idea is highly debated in the science community. but taking into account the fact that science has been unable to explain the processes that led up to the Planck epoch and have been unable to go back any further, Penrose's idea begins to look more plausible. Penrose's idea basically states that our current universe did not simply emanate from nothing, but was in fact the product of a dead past universe. Roger Penrose is highly respected and regarded in the science community as a well-accomplished physicist and mathematician with his known contributions to the general theory of relativity and cosmology. Penrose was awarded the Wolf Prize in Physics, an award he shared with the late Stephen Hawking back in 1988. His most notable award is winning half the Nobel Prize in Physics in the 2020 awards season for the discovery that black hole formation is a robust prediction of the general theory of relativity. Penrose is currently regarded as one of the greatest minds in both theoretical and quantum physics in the world. His theories are well respected, which is why when he postulated the hypothesis of a cyclic mode of universes, it was widely looked into by the science community. When he published the book Cycle of Times, Penrose revealed that he worked with an offshoot of Einstein's theory of general relativity to postulate his own hypothesis of conformal cyclic cosmology. In contrast, Penrose's theory actually opposes the original model of general relativity put forth by Einstein, as it doesn't follow the multi-dimensional theory that most scientists have come to know and accept. Instead, Penrose's theory states that the universe doesn't exist in multiple dimensions all at once, but instead exists in phases, with the death of one phase giving rise to the birth of the next. In his published paper, Penrose revealed that he discovered evidence of the existence of a previous universe based on centric circles which he discovered while studying multiple versions of the cosmic microwave background (CMB). He reviewed the data from the discovery he had observed that an earlier universe might have quite possibly existed, with its last feeding conditions leading to the Big Bang that created our own. In his published papers, Penrose stated that the Big Bang was a result of the final stages of this pre-existing universe, which he stated was filled with billions of evaporating black holes that had consumed all cosmic matter within their own universe. He went on to state that the final stages of this pre-existing universe was filled with evaporating black holes which at the last stages of their existence were nothing but photons that existed outside of space and time. According to his research, these last remaining photons of the pre-existing universe were incredibly similar to the first photons that we observed during the very first milliseconds of the Big Bang. This essentially means that the singularity that resulted in the Big Bang is mathematically or otherwise equivalent to the cold, expanded pre-existing universe. The basis of Penrose's cosmic conformal theory was based on his study of the cosmic microwave background. This is essential because the CMB is the earliest scientific picture we have of the early stages after the Big Bang, as it shows the most primitive electromagnetic radiation that engulfed the early stages of the universe. The cosmic microwave background can be found all over the universe and currently serves as the most important source of data reference, showcasing the radioactive and thermal state of the early universe. The CMB dates back to when the early universe was cold enough for protons and neutrons to be stable enough to fuse, forming the very first atoms during a period known as recombination. This period of recombination has been observed to have existed around 380,000 years after the Big Bang. Although in our study of the Big Bang we have dealt with fractions of a second, this might seem like a long period of time, but considering the universe is over 13 billion years old, it is still a relatively small interval. The CMB can be observed using a dedicated radio telescope, which would show a faint glow of multiple colors existing in the space between stars and galaxies. This glow is not associated with any other cosmic object in the universe, but is simply a relic frozen in time from the earliest stages after the Big Bang. Following his study of the CMB, Penrose was able to observe data from this early stage in the universe's existence, at which point temperatures had dropped low enough that protons and electrons could fuse, forming atoms. Following his analysis of the cosmic microwave background, Penrose published his report alongside 3 other authors, which included Pavel Nurovsky, Daniel And, and Christoph Antoni Meisner. Together, they had observed anomalous points on the CMB that had previously been discarded by other scientists and seemed to give them a new direction into the knowledge of the origin of the universe. In their report, they stated that the observed anomalies could possibly be remnants of energy sources and signals from evaporating supermassive black holes that might have filled the universe that existed before our own. They were able to attribute these anomalous observations to evaporating supermassive black holes simply because black holes are the only cosmic objects in the entire universe able to produce and withstand a powerful enough level of energy comparable to the Big Bang. The report stated that there is indeed evidence within the CMB that shows remnants of collisions of supermassive black holes in a pre-existing universe, as they are essentially the only structures that will be left powerful enough to leave such ripples of gravitational waves in any universe. Gravitational waves produced by the collision of these supermassive black holes were powerful enough that they not only permeated through the Big Bang, but remained evident well after our early universe had cooled enough. In order to support his theory of cyclic conformal cosmology, Penrose examined the implications of the second law of thermodynamics, and although much of his current theory stems from theoretical physics, it disagrees with popular postulations that information is destroyed once matter enters into a black hole. The idea that once matter or light enters beyond the event horizon of a black hole, it becomes essentially destroyed and can never be retrieved is a popular notion widely accepted by most scientists. But according to Penrose, black holes are way more than cosmic voids that swallow up matter and light in the universe, but instead they essentially break down energy into photons that are capable of existing beyond space and time. These photons can survive as long as black holes exist and can very well be the foundations of the Big Bang of a subsequent universe once the current universe dies out. Penrose's theory further states that over infinitely long periods of time, which could very well be trillions of years, all matter and energy in the observable universe completely breaks down into photon energy in a dead, cold, expanded universe. Based on his theory, the period from a Big Bang at the birth of a universe to the infinite expansion at the end of the same universe is called an eon. The corresponding expansion and oblivion of one eon becomes the foundations and subsequent Big Bang of the next eon cycle. At the critical point between the end of the previous eon and the start of a corresponding one, the laws of space and time are irrelevant, hence making the start of the new eon seem quite small relative to its observers. This simply means that the inhabitants of an eon or current universe can only observe to the point at which their universe starts, as beyond that point, space and time breaks down beyond their observation. Penrose believes that the singularity which resulted in the Big Bang isn't much of a complex mystery in itself. He states that following his observation of recorded black holes in our galaxy, he found the presence of similar singularities, albeit much smaller, beyond the event horizon of these black holes. He also states that with his study of the CMB, he observed streaks of circles that appear to be extremely red-shifted photons, which could possibly have been present within the black holes of the previous universe, and some have found their way into our existing universe. From a layman's point of view, these circles might not look like much, but to a well-grounded physicist, it translates to low-energy emissions from black holes of a previous universe. Penrose believes that the large amounts of cosmic energy consumed by the black holes of the previous universe could find their way into the future Big Bangs of a subsequent universe following an unimaginable period of cosmic expansion. However, Penrose's theory that the universe will cease to exist after a period of infinite expansion does not simply support his own theories of a previous universe, but actually contradicts a widely accepted theory on the end of the universe, the Big Crunch. Previously, scientists had postulated that the current expansion rate of the universe was still the result of the expansion of the Big Bang, and that the universe was still in the mid-stages of its existence. They hypothesized that as the universe grew into its latter stages, the gravitational pull of matter across the cosmos would eventually slow the rate of expansion and essentially begin to pull all matter together. The theory of the Big Crunch believes that the ultimate fate of the universe would be the result of the force of gravity exerted by every body of mass across the universe. This powerful force of attraction would eventually lead to a contraction on a cosmic scale that would lead to the ultimate collapse of the entire universe. They believed that the Big Crunch will eventually condense the entire universe into a hot and dense enough environment that it would effectively cause another Big Bang, ultimately kickstarting the foundations of a new universe. The similarities between the Big Crunch and Penrose's theory of the end of one universe causing the start of another are uncanny, except the theory of the Big Crunch is wrong in one regard. The expansion of the universe is not and will not be slowing down at any point in the future. Current data from several astronomical observations have it that the correct expansion rate of the universe is not slowing down, but the expansion rate of the cosmos is actually accelerating. The analysis indicates the acceleration at which galaxies and stars are moving away from observing telescopes here on Earth is increasing with time. The result of these observations was proven with the study of the explosion of supernovas and how the light from this cosmic phenomenon traveled across the cosmos. The rapid acceleration rate of the universe completely discredits the theory of the Big Crunch, as it appears gravity has little or no effect on the expansion rate of the cosmos, much less strong enough to cause a complete collapse of the entire universe. These observations are universal and not only discredit the theory of the Big Crunch, but further solidify Penrose's theory that the universe will expand to a point of complete disintegration aided by black holes with the presence of photons giving rise to the birth of a new universe. Penrose's conformal cyclic cosmology theory remains highly debatable in the science community as other cosmologists and scientists continue to study the cosmic microwave background to find the same evidence with which Penrose uses to support his theory. It still remains unclear as to if they will come to the same conclusion, but it remains a high possibility as it serves as the most plausible explanation for the singularity that resulted in the Big Bang. For now, Penrose has much of the science community fixated on the CMB, trying to decode the same clues with which he postulates his theory. Most scientists that have dissected Penrose's theory of a cyclic universe have asked a very fundamental question that I'm sure is at the back of everyone's mind. How is it possible that a very cold and empty universe can somehow result in an incredibly dense and hot universe from another perspective? Well, according to Penrose himself, the answer lies in a rather complex mathematical procedure which is known as conformal rescaling. This procedure is a geometrical transformation in which the effect alters the size of an object but has no effect on its shape. Penrose explained that the correlation between the cold dense state of a dead universe and the hot dense state of a new universe could be related with respect to the shapes of their space-time but not their size. It is a fairly complex concept to grasp how distinct objects can be identical in shape and have different sizes, but Penrose argues that size becomes irrelevant under such extreme physical and quantum environments. The concept basically states that size is relative and simply irrelevant in that our current perception of size could simply be infinitesimally small to the subsequent universe that would arise from the Big Bang caused by the death of our universe. In the same regard, the previous universe that preceded our own could have simply existed in what we might observe as infinitesimally small compared to our perception of size. The concept of conformal cyclic cosmology simply states that one universe goes from cold and old to young and hot, not following the common physical principles of cause and effect. In this regard, size is not the only factor that becomes irrelevant, as time as well becomes a non-factor. From the perspective of an observer in the expanding universe, the cold and empty state would exist forever in its temporal timeline in the same regard. The hot dense state will give rise to inhabitants that will observe it and its timeline. This states that at some quantum, unexplored and undiscovered level, the previous universe that predates our own is still expanding, devoid of life and black holes, with only photons present in that current universe. This is all within the realm of speculative physics, as there is no evidence or observable proof to show that any of these things have existed or are currently existing. These ideas begin to border on the limits of our knowledge of physics, with realms that become almost indistinguishable from philosophy. But then again, Penrose's theory leaves room for other interpretations of quantum mechanics in which multiple worlds result from a single Big Bang event. In this theory, there are several measurements of heat and density that result from a single Big Bang, all of which eventually play out on different timelines. In this scenario, there is a multiverse of universes where there are endless versions of you and equal versions of Earth, all playing out with different scenarios. In those multiverses, you might live in a different country, might have won the lottery, or probably been hit by a bus, who knows? These parallel universes are all existing simultaneously, will most likely end the same way to kickstart the next infinite layer of multiverses. Some scientists believe we might be able to observe these parallel universes, as they might leave imprints as they collide with our own. This spin-off from conformal cyclic cosmology isn't one Penrose agrees with, but it's still as theoretical and speculative as his original theory. Penrose's theory of conformal cyclic cosmology offers some answers, albeit speculative, to the origins of our current universe, but it still leaves a big question unanswered. Even if our current universe is part of a long chain of pre-existing universes, how did the entire cycle of universes begin? What gave rise to the very first that began the chain of eons and universes? This still brings us back to the very fundamental question of whether the universe, or universes in this case, arose from nothing, or was some being responsible for the creation of the universe as we know it. We've stretched the limits of physics and quantum mechanics, none of which can fully explain the origin of the universe with our current knowledge of science. But looking at myth and folklore, Penrose's cyclic model of the universe has a striking resemblance to the Norse mythology of the Ouroboros. The ancient serpent Jörmungandr is the child of the Norse god Loki, who consumes its tail, and the circle in turn sustains the balance of the world. Or it could simply prove the existence of some divine being at the beginning of all creation, responsible for kick-starting the very first universe, which goes on to repeat the cycle of expansion and creation to the point of creation we are now in. What do you think is behind the curtains of nothingness at the start of creation?